Hello, my dear students. Today we are here to discuss about the chapter haloalkane and haloarene. Now, the chapter haloalkane and haloarene is the chapter from our organic chemistry. So, the first point in your mind should be, what is organic chemistry? Organic chemistry is the chemistry in which the study of carbon compounds स्टडी ऑफ कार्बन कंपाउंड्स में आपके माइंड में क्वेश्चन आता है, कार्बन डाइऑक्साइड इज इट ऑर्गेनिक? तो आप सोचेंगे यस इट इज ऑर्गेनिक, बट नो. स्टडी ऑफ कार्बन कंपाउंड और स्टडी ऑफ द हाइड्रोकार्बन, study of the hydrocarbons including heteroelements. Heteroelement is the element other than carbon and hydrogen, including halogens represented by X. Heteroelements are halogen including chlorine, bromine, iodine, fluorine. Astatine is radioactive, that can't be considered in haloalkanes or haloarenes. Other than halogens, we can include nitrogen, oxygen, sulfur. So these heteroelements along with hydrocarbons gives organic compound. Suppose we have the example haloalkane. Simply we are writing it as RX. So R is a hydrocarbon chain. CH3 CH2 Br. Here halogen is bromine and CH3 CH2 is the hydrocarbon part. This hydrocarbon part along with this heteroelement gives haloalkane, and this haloalkane is an organic compound. This organic compound will be studied in the branch of chemistry. That branch of chemistry is the organic chemistry. So this is the chapter of organic chemistry that comes first, that we will have to study as haloalkane and haloarene. Hope so this point will be clear to you. Now halogenated compounds will remain in our environment due to the resistance to break down by soil bacteria. So we can say the haloalkane and haloarenes are the halogenated compounds. Halogenated compounds are not biodegradable. If they are not completely break down, they cannot be easily decomposed by bacteria, so it can be non-biodegradable. non-biodegradable. If anything which is non-biodegradable to our environment is harmful in some or the other ways. So we will study the positive and negative impacts of the haloalkane and haloarene also. But each and everything in our environment have positive as well as negative impact. Positive and negative impacts it means pros and cons. Positive and negative impact. Suppose a compound halothane is a halogenated compound. It is used as a medicinal compound. And chloroquine, pronunciation is something similar to quinine. So it is effective in the treatment of malaria. This chloroquine is effective in the treatment of malaria. So it is positively used. And if anything which is non-biodegradable to the environment is negatively impacting to the environment. So this is a general term that halogenated compounds persist. Persist, it means remain, or you can say sustain in our environment due to their resistance to break down by soil bacteria. Soil bacteria, it means the microbes which decomposes the organic matter into inorganic substances. Now to read about the haloalkane and haloarenes. After studying this chapter, you will be able to write the IUPAC name of the compounds, their physical properties and chemical properties will also be cleared in your mind, how they are prepared and how they can be used in other fields or for the preparation of the other organic compounds. So what are the objectives of studying the haloalkane and haloarene? Let us discuss about the objectives. If we talk about the objectives, after studying this unit, you will be able to name the haloalkane and haloarenes. As per the IUPAC nomenclature. What do you mean by IUPAC nomenclature? IUPAC is the most authentic nomenclature to write the names of organic compounds. It stands for International Union of Pure and applied chemistry. After writing their names, you will be able to describe the reactions involved in the preparation of haloalkenes. It means the preparation of haloalkenes will be clear in your mind. It means how to prepare haloalkenes by having different kind of substrates with reagents. You can easily prepare the haloalkenes as well as the haloarenes. And you will understand the reactions of their method of preparation, how they will undergo, what method is used, what kind of reagent is used, how many types of reactions are involved in the preparation of haloalkane and haloarene. So it will be clear in your mind regarding method of preparation of haloalkane. Now you will be able to correlate the structures of haloalkane and haloarene. Suppose haloalkane is generally written as Rx, but haloarene is written as like that. This benzene ring is aryl group. This benzene ring is aryl group here. After correlating the structure of haloalkane and haloarenes, we will use the stereochemistry as a tool for understanding the reaction mechanism. Now the term stereochemistry is the chemistry of organic compounds in space. It means how the atoms or the group of atoms or group of atoms around a central atom is arranged in space is related to stereochemistry. Suppose we have CH4. It is not it is a organic compound but made up of only carbon and hydrogen. No heteroelement is there, but it is the simplest hydrocarbon, we can say. So the stereochemistry of CH4 will be like that. All the hydrogen atoms are present around the central carbon atom in space, where two hydrogen atoms are in the plane and one is above the plane and one is below the plane. Above the plane, it means towards the observer, and below the plane is away from the observer. So we can represent this compound or molecule in space in the form of stereochemistry. So the stereochemistry can be a tool for understanding the reaction mechanism. How the atoms or the elements changes their position in space is related to stereochemistry. After the stereochemistry, we will have the applications of Organometallic compound. Now the term organometallic is used here. The organometallic compounds are the compounds having metal carbon bond. Suppose we have R, Mg, X. Here metal is magnesium and R is the alkyl chain containing carbon atom. So the metal carbon bond represents the organometallic compounds. So the organometallic compounds and their application will be clear in your mind. Coming towards the environmental effects of polyhalogen compounds. Polyhalogen compounds are the compounds having more than 2 halogen atoms in the organic compound. Suppose CCl4, it is a non-polar solvent. This CCl4 is the carbon tetrachloride having 4 halogen atoms, so it can be considered as polyhalogen compound. Next is the chloroform. Chloroform is CHCl3. Trichloromethane is a polyhalogen compound. It is in the gaseous form. So, the polyhalogen compounds and their environmental effects will be clear in your mind after completing the chapter. So this is all about the objectives of the haloalkane and haloarenes. So first of all, you have to study the IUPAC nomenclature of the organic compounds such as haloalkane and haloarenes. So let us discuss the general introduction along with the nomenclature of the following compounds in our video. Hope so this point will be clear to all of you.